Hello everyone. In this video, I want to discuss the second problem in homework 10. Let's see the description of this problem. The professor asked us to select the definitions of property and properties of this process and explain our understandings. The first one is a stationary process and it could be found on page 31. The definition is if its expected value is a constant and its oscillating relation depends on T1 minus T2 only. Property is ext equals eta, and its expectation of xt plus tau times xt equals r tau. And actually, if mean is a constant and not correlation constant over time, then the ext has a second order. The second one is independent increment process. It could be found on page 24. So the definition of this one is the property of xta minus xtdb is less than or equal to x1 and xtc minus xtd is less than or equal to x2 equals the property of xta minus xtb less than or equal to x1 times the property of xtc minus xtd less than or equal to x2. So the behavior in one time interval has no influence on the behavior in another time interval. The third one is Markov process. It could be found on page 25 to 26. So the definition is the path has no influence on the statistics of the first and pxx. We have that px1 equals px1 and x2 equals x2, xn equals xn for the property mass function. If xi is a Markov process, then it's determined by second order problem masses. But if it's a sequence of independent random variables, it's statistically determined by the first order probability masses. And the most important thing for Markov process is the next state only depends on current state. The fourth is a normal process. A process is said to be normal if the random variables xt1, xt2, xt are jointly normal for any NATI, and let f(x) equals 1 over square root of 2 pi to the power of n times the square root of the determinant c times e to the power of negative 1 over 2 times transportation of x minus eta times the inverse c inverse x minus and times x minus eta. Eta equals ex and c equals expectation of x minus eta times transportation of x minus eta. And actually the distribution of each individual random variable is normal. Next one is strict sense stationary. It could be found on page 29 to 30. And the definition is xt is stationary in strict sense if the statistics is not affected by a shift on the time axis. And let f(x) x1, x2 to xn, t1, t2 to tn equals fx t1 x1, x2 to xn, and t1 plus epsilon, t2 plus epsilon to tn plus epsilon, and for any t I and any epsilon. So we have little fx xt equals little fx x, and the expectation of xt equals 0, and little fx x1 x2 t1 t2 equals fx x1 x2 t1 minus t2, and RT1 T2 equals R T1 minus T2 equals R tau equals R negative tau. So the statistics are not affected by a time shift. It only depends on the time interval. The sixth one is what knows. It can be found on page 41. So the definition is VT the zero mean what knows if RV3 T1 T2 equals Q T1 times delta T1 minus T2. And the expectation of x t squared equals the integral from 0 to t q beta d beta. So signal has equal power at all frequencies, and the signal values at energy points are uncorrelated and impact dependent. The seventh is the mean ergodic. It can be found on page 48. So x2 is said to be mean ergodic if lambda t to the infinity 1 over 2t times integral from negative t to t that xt dt equals expectation of xt. And we have another formula. So the behavior of the mean ergodic process in a long time can be representative of its overall statistics. The last one is nonlinear. It can be found in the closed-tree homogeneity. So it's a sequence of random variables for which at a particular time the conditional expectation of the next value in the sequence is equal to the present value regardless of all prior values. And so the property means that a martingale is a sequence that on average doesn't grow or shrink.